That's 10 points, not 10%. So yeah, you get 10 points back, which is roughly 7% of the points back on your exam. So, okay, yeah, certainly a good idea to do that. As of now, less than half the class has submitted the redo. So please do make sure you use this opportunity. Okay, midterm regrade requests are due tonight. After tonight, we will not address the regrade requests on your midterm. So please make sure you've gone through your exam. Okay. Tomorrow morning, there'll be one-on-one check-ins with Diksha. You can sign up for these check-ins at edpost number 141. If you want to find a certain ed post, go to ed, click the search bar, and then put #141. So these check-ins are basically scheduled as post-midterm check-ins, which means if you want to talk about your exam, if you want to talk about the course in general, anything of that sort, you can have time with the instructors to discuss it. Okay, Thursday's self-check will be extended to Wednesday night because we haven't covered dictionaries yet, and dictionaries will be covered on Wednesday. Okay, lost section. So we had our first lost section last week. We had 3 people come, but we went over a lot of exam level problems. We slowly reviewed a lot of material, and the feedback we got was pretty positive. There's a recording of the lost section and the slides posted in an ed post titled lost section. I would highly encourage those of you who can make it to come to the next lost section. It's a great place to reinforce concepts. We know that we go fast over the summer, so then there's this resource where we go a little bit slower. Okay. Before we start, 2 things I wanted to reiterate. I've reiterated it before in discussion and also in our midterm review session, but I wanted to say it again, especially today, because the material is a little bit hard. These are the 2 rules from Professor Hilfinger. Used to be a professor at Berkeley. As you can tell, I'm slightly obsessed with him. The first rule is DVC, which stands for don't be clueless. What this means is that oftentimes we'll present material that is somewhat challenging. Don't let any material be a mystery to you, okay? If you find that you don't understand what's going on or how something works, don't just put it aside and say, I'll come back to it later. Ask questions, show up to office hours, and don't remain clueless. If you're stuck, it's your responsibility to get unstuck. Okay. The next is RTM, modified slightly. RTM stands for read the manual. What this means is that now you're learning Python. There are so many resources available online beyond what we give you in CS10. So if you're stuck, if you don't know how a function works or something of that sort, just Google it, right? Look it up, look at Python documentation. I'm not saying that you should use the web to help you with assignments or exams or anything of that sort. What I am saying is, if something's unfamiliar to you, use the resources at your disposal, both in the classroom and beyond. Okay. Now we'll start off with our topic for today, which is list mutation. So as always, we'll start with just some definitions. Firstly, what does mutation even mean? Mutation is the act of altering the value, which is mutating, of a mutable object. So anytime you alter the value of a mutable object, what you're doing is mutation. So then what's a mutable object? Well, a mutable object is an object that supports mutation. So in other words, a mutable object is one whose value can alter or can be changed over time. Okay, then what are some examples of mutable objects? Well, lists and dictionaries are the main ones that we're going to be focusing on in CS10. We also have sets and all sorts of other examples, but today primarily we're going to be focusing on lists. Following from that, we also have immutable objects. Immutable objects are those objects that don't support mutation. In other words, their value does not get altered over time. Now, this can be somewhat tricky because in the examples I'll give you, I'm saying, okay, numbers are immutable, Booleans are immutable, strings are immutable, so are ranges and tuples and so on and so forth. But does that mean that every time I assign a variable to a number, I can never change its value again? No. It means something else. And what I want you to do is pay close attention to the examples I'm going to show you to understand what it means, okay? So now we're going to talk about assignment and references. Let's start with definitions again. And this is the last slide with definitions before we proceed to some examples. So bear with me. Firstly, references. What do I mean by references? When I say references, I'm talking about variables that are assigned to mutable objects. Okay, so if I take a variable x and I say x is equal to some list, since a list is mutable, I'm going to call x a reference to that list. Okay, that's just a piece of jargon I like to use. Then we have this new tool that we're going to provide to you, which we will call environment diagrams. Actually, it's called environment diagrams in all of CS, but yeah. Environment diagrams are a visual tool to help keep track of variables and their values. So when you have all sorts of references pointing at all sorts of lists and other mutable items, it becomes pretty non-obvious what's happening in your code. A way to consistently and systematically keep track of what's going on is by using environment diagrams. I would say the goal of this lecture is not for you to memorize all these definitions or write them down, but truly understand and grasp the idea, the motivation, and the use cases of everything we're presenting to you. Slides will be available later, so you can certainly take notes later also. Okay. Then we have this one rule of environment diagrams that you should keep in mind. The rule is, whenever you assign a variable to a mutable object, you draw a pointer, which is an arrow, from the reference to the object, okay? And by reference, I'm just talking about the variable that you assign to the object. Now, this is a mouthful. It might be abstract. We're going to jump into examples. Before we do, any questions? Is everybody happy with the term reference, environment diagrams, variables, assignment? Okay. So, well, following from what I just told you, if you have a variable that refers to or is assigned to an immutable object, for instance, if you have a variable that you say something like x is equal to some number, so x equals 7 or x equals the string hello, you're not going to draw any pointers, okay? Because those are immutable types, okay? So let's start off with an example. If you'd like to code along, there's this link that I put up here, that's pythontutor.com. You can open it up on your browser and then code with me, basically. And it might be a good exercise to, build intuition for how these things work. Okay. So the first example we're going to do today is we're going to run these two assignment statements, okay? So in the first case, what I'm doing is I'm saying A is equal to 3, B is equal to a list containing 3. My first question is 3 a mutable value or an immutable value? Is a number mutable or is it immutable? What do we think? Immutable, right? As presented before. Great. So, well, A is bound to an immutable value. What does that mean? I don't draw any arrows. Okay, so let's run this and let's see what happens. So now A is set to the number 3, and we don't really see any arrows going anywhere. Okay. This is just an example to help you build intuition for how you can draw environment diagrams and how they can help you understand what code is doing. Now, B points to this list containing 3, or the variable B is assigned to a list that contains an item 3. My question to you is a list mutable or immutable? Mutable, right? Okay, so then in that case, well, we must draw an arrow. So let's draw our little arrow. And you can see that B, the reference, has an arrow or a pointer to this mutable object, which is a list that contains 3. Can I see thumbs if so far everything is good? So thumbs up means I get it. Thumbs to the side means slow down a little. Thumbs down means I don't know what you're talking about. Okay, so most of us seem to be comfortable with it. I'll go over it one more time. When I take a variable and I assign it to an immutable type of data, which is a word, a number, anything of that sort, a tuple, I don't draw arrows. When I take a variable and I assign it to a mutable type of data, which means a list, perhaps a dictionary, then I draw arrows. Does that make it clearer? Can I see thumbs again? Awesome. Okay. So let's proceed. So this is the example. I put up all the code on the slide so you can refer to it later. Okay. Important observation in the code that we just saw. When I use this little square bracket notation where I put in the number 3, I notice that a new list object is created, right? This yellow box didn't just come out of nowhere. So whenever you have these square brackets and you put in items inside it, a new list object is generated. Then whatever variable you assign to this value inside a square bracket, you draw an arrow from it to the object you created. Thumbs if this makes sense? Awesome. Okay. All right, so we'll proceed to the next example. Yeah, so just to reiterate the point I made, when you have a square bracket and you have item 1, item 2, and so on and so forth, you create a new list object. And then when you assign a variable to this, you simply draw an arrow from your reference, which is the variable, to the object. Great. Now let's do another example, or let's build upon our example. So let's see what's going on here. Well, it starts off the same, where you have A set to 3 and B set to a list containing 3. So far, so good. And now what happens? Well, C is assigned to be A, okay? And now this is an interesting question. How do assignment statements actually work in Python? What's going on behind the scenes? So let's take a look. Whenever you have an assignment statement, which means you have one equal to sign something on the left and something on the right, Python will first ignore what's on the left. It will evaluate what's on the right, okay? And then after it has the value of this thing on the right, it'll assign it to whatever was on the left, okay? So you have a variable on the left, you have something on the right, whatever's on the right gets evaluated, and then whatever value you get, you assign it to the thing that's on the left, using our two rules, okay? So if the thing on the right evaluates to an immutable object, you don't draw arrows. If the thing on the right evaluates to a mutable object, you draw an arrow. So let's use this in our example, okay? Well, I have C equals A. Firstly, what's the value of A? 3, right? The number 3. And is 3 mutable or is it immutable? Immutable, right? The value of the number 3 won't change. 3 is always 3. Great. So then do I draw an arrow? Who thinks I should draw an arrow? And raise your hands if you think I shouldn't. Okay, so as most of you said, we won't really draw an arrow. A evaluates to an immutable data type, which is a number. So there's no need to draw an arrow. I'll just make another copy of 3, and then A just becomes exactly that, okay? And now let's look at this through the next statement, which says D is equal to B. So I do the same thing again. I first look to the right-hand side, and I say, okay, right-hand side, what are you? So in our case, what's B? B is a pointer to this list that contains 3, okay? Or you might say B is this list that contains 3. So my first question is the list containing 3, or is the value of B mutable or immutable? Raise your hands if you think it's mutable. Okay, raise your hands if you think it's immutable. Okay, so everyone's correct, but everyone's a little scared. Raise your hands up high, it's fine. If you get it wrong, you learn even more. Okay, so now we realize that B is mutable. Why? Because it points to this list that contains 3. So I evaluate B. Great, I get B is a pointer to a list containing 3. Now, whatever I get as the value of the right-hand side, I assign it to D. In this instance, since what I got was a mutable value, I have to draw a pointer, okay? So then my D becomes a pointer to the very same list. Now this is interesting. Why didn't we create a new list? Why do we have a pointer to the same list? 2 ways to look at this. The first one I'll give you. The second one, first I'll ask if anyone has any ideas. The first one is the value of B is just this arrow. Where that arrow points, we really don't know. So when we set D to B, we take this arrow, just make a copy of it, and then it goes wherever it's going. Okay, so that's one way to think about it, where the value of B is literally just the arrow, and I copy over the arrow, okay? There's another way to think about it, which ties back to something I said a few slides ago about creating a new list. Does anyone remember or want to, try or come up with a guess? In what circumstance do we create a new list object? It's okay if you get it wrong. What's different about B equals square bracket 3 and D equals B? What's missing? Yeah, you're whispering, but say it out louder. Precisely, right? There are no square brackets. We haven't started a new list. We didn't make a square bracket and put in items. This is not to say that using square brackets is the only way to create new lists. This is to say that that's the way we've seen so far, and that's missing, okay? So since we didn't use our square brackets to create a new list, no new list is created, which means it'll point simply to the exact same list which was created in the first instance. Using either the first way that I told you or the second way that I told you, can I see thumbs if this piece of code in the diagram makes sense? Kyle, you got a question? Oh, sorry, I said thumbs. You did this. My bad, my bad. Can I see thumbs again? Okay. Is anyone a little bit clueless? Wants me to say it one more time? Okay, you'd like me to say it another time? Let's do it. Okay. This time I'll use the whiteboard instead of the code there. Initially, I started off with A, and I only look at the right-hand side. The right-hand side is an immutable value. It's just the number 3. So I draw no arrows. I just set A to 3. Great. Now I have this B is equal to a list containing 3. I start by looking at the right-hand side. In the right-hand side, I see these square brackets and I see a number inside it. Whenever I see a square bracket which contains items in it, I draw a new list. So I create this list object that has 3 inside it. Now I've evaluated the right-hand side. It created a new list object. I look at the left-hand side, there's the variable B. I point B to whatever I made on the right-hand side. Since this is a list object and it's mutable, B will contain an arrow or a pointer to it, okay? Next, I set C to A. Okay, so another assignment, I look at the right-hand side. What is the right-hand side? The right-hand side is A. So I evaluate A. In other words, A is a variable. What value does it contain? A contains the value 3. Great. So I have the value ready. And now I set C to the value. Since the value is a number, it's immutable. So I just set it to 3. Okay. Now I look at the next assignment statement that says D is equal to B. I now see, okay, B, what value do you contain? In other words, I evaluate B. B contains a pointer to 3. So the value of B technically is just this pointer, right? So I say, okay, B contains this pointer. Let me copy the pointer over. Wherever it goes, and I set that to D. So now D also contains a pointer to the same list. That's one way to look at it, right? The other way to look at it is, since B contains a list and a list is a mutable data type, whatever variable you're assigning to it must also contain a pointer to it. So these are the 2 ways to understand that concept. Is it fine now? Good to proceed? Okay, any other questions? Can I see thumbs one more time? Awesome, okay. So now we're going to talk about operations that we can perform on lists that mutate lists and that change their value. Okay. So the first such operation is what we call assignment. The syntax for assignment, I've given up on your screen there. Can everyone in the back see the screen over here? Because every time I make it larger, it just zoom disappears. Okay, cool. So here's how I would interpret this statement that I've given you. Anything inside angles, what I'm trying to say is don't take this literally. This is just a hint, okay? So the first thing I see is list reference, which means the variable I bound to a list. The second thing I see is I see a square bracket. Inside it is the index, and then it equals a certain value. What this expression does is it says list reference. Which list do you point to? Finds the list. At a certain index in that list, change the value it contains to the value that I just gave it. Okay, that's all it's doing. And so obviously speaking about this isn't the clearest way to present it. So we'll just look at what's going on. So let's see. A is set to 3, B is set to a list containing 3, C is set to A, D is set to B. Why did I speed through it? It's the same example you saw in the last slide. Now something interesting is happening. I'm setting E to D. Okay, so can anyone tell me what's going to happen now? And if the answer seems intuitive, it is intuitive. I'm not trying to trick you. Yeah, go ahead. Precisely, right? So we follow our rule. D, what are you? Well, D just contains a pointer to a list. So then I set the variable A to this pointer or a copy of this pointer, right? So then E just points to the same exact list. Okay. Question, yeah.
So for all the values set to
Exactly. Exactly. There's just one list, and everybody else is just pointing in that one list. If you remember a few lectures back, we introduced the notion of memory addresses, right? I think Maddie spoke about it, where everything just has the address of a certain object. That's exactly the same idea. It's just visual. Okay. And now what I'm doing is I'm saying D, whatever item you have at index 0, I want you to make it 5. Okay. So I look at D, which list does D point to? Well, this exact list. And now what do? I change the item at index 0 to 5. But then something interesting happens. Every single reference that pointed to that list now points to the changed version of that list. And this is the idea of mutability. If you had A is equal to 3 and B is equal to 3, and then you said B equals B plus 1, A wouldn't change. But if you have multiple variables or multiple references pointing to the same list, and you change that list, all of a sudden, the list that these references point to, all of them have changed now. Can I see thumbs if that idea makes sense? Okay, awesome. So now, observation that we had from this example, if we mutate a list, then all references to that list will now point to the changed list. That's simply because there was only one list to begin with. Okay. Now I had, I believe, a slightly more challenging example. So let's see what happens here. This is basically a way for me to test, can you apply rules in unfamiliar situations? Extremely non-intuitive. This happens all the time. Like you'll be presented with rules and then you have to think of edge cases, but we'll try it together. Okay. First, I see A is pointing to a list, right? I see the square brackets, so I just make a new list. So let's start with that. So I look at the right-hand side and I start a new list. Great. What's the first thing in the list? The first thing in the list is 3. 3 is just an immutable value, so I put it right there. What about the next thing in the list? What do you think happens? Raise your hands if you think another arrow is coming. So raise your hands if you think I'm going to draw another arrow on the board. Okay, raise your hands if you think I'm not going to draw another arrow. Raise your hands if you'd rather not answer and wait for me to explain it. Most of us? Okay, I understand. I was in the same position. Okay, so now rule number 1. Every time I see brackets and an item inside of it, I create a new list object. So as soon as I see brackets and 4 inside of it, immediately I just make a new list. So let's do that. I create a new list object, 4. Rule number 2 that I haven't made explicit, but now I will. Every single item in a list can be treated just like these variables. These items in a list are themselves worthy of being treated like variables or references. Okay. So the first item in my list is a variable that contains the value 3. The second item in my list is a reference to a list which contains 4. Now, a reference to a mutable object warrants the use of an arrow or a pointer, right? So what am I going to do? Well, the second item literally is a pointer to the list containing 4. Okay. And then the third item in my list is 5. And well, what is A? A is a pointer that points to whatever list we just made. So a lot of abstraction is going on. At each point, I'm focusing on one little piece of the puzzle. And we'll see what it looks like on Python Tutor, and then I'll ask you for questions. So that's precisely what we expected. I create a new list. That's when this list gets made. The first value is 3. The next value, the first thing I see is I'm using square brackets and something inside of it. So I make a new list. The first value I treat it as just a reference. So it points to this new list. The third one is 5. 5 is not mutable. So I just put in 5. Can I see thumbs if this makes sense? Any questions? Yeah. Yeah, let's go over it again. This one is slightly tricky, so I'm happy to repeat it again. Okay. So now listen very carefully, step by step, to what Python is doing behind the scenes. First, all I'm seeing is I have an assignment statement. Let me look at the right-hand side. the first thing I observe is that I have these two outer square brackets. So without even thinking, I create a new list. Okay. Then I treat every single value that's going inside this list, or every single index in this list, or every position in this list as its own variable, using the same exact rules that we use for assignment statements. Okay. So it's almost like saying, I'm making a list and I'm saying item 1 equals this, item 2 equals this, item 3 equals this, but I'm just doing it in my head. Okay. So let's see what that means. The first item of the list points to an immutable value. When some variable points to an immutable value, we don't ever draw arrows. Okay. So all I'm saying is treat these empty boxes or these empty spaces in a list as variables themselves. The first one contains 3. 3 is immutable, no arrows needed. I put in 3. The next one, before I do anything, I've observed square brackets, right? I know that whenever I see square brackets and something inside of it, I need to create a new list object. So before I even think about assignment, I go ahead and I create a new list object. It contains 4. Okay. I go back to what I was doing. The second item or the second position in my list points to this list containing 4. Why? Why points? Because the list containing 4 is mutable. So I almost treat it like an assignment statement where I'm saying position 2 equals list containing 4. How might I do that? Well, I must draw a pointer because the list is mutable. The third item, I'm assigning it to the number 5. 5 is immutable. I don't need to draw any arrows. So I just put in 5. Okay. And now I zoom back and I say, what was I doing? Well, I was creating a list and assigning it to the variable A. So I say A, you'll just point at this list. Can I see thumbs that this was clearer? Most of us seem to be happier. Any questions? No questions thus far? Okay. So now we'll move on to the next line. The next line is saying B equals A. So does someone want to tell me what this will do? Yeah. Exactly, right? It says, okay, B is equal to A. First, let me evaluate A. What is A? A is literally just this arrow. Great. Now I know what A is. So let me create a variable B and let me use the same arrow there. And it points to whatever A was pointing to. Another way to think about it, what is A? A is this list right here. So then if I'm assigning B to a list, I must draw an arrow to that list. So I draw an arrow to that list. Can I see thumbs if this made sense? Any questions? Okay. So now B points to the same thing. Now I have another one. I'm saying value is equal to A bracket 1 bracket 0. So an interesting thing is happening here. We're not creating new lists. Okay. This is the syntax for indexing into a list. When I have the name of a list and in front of it I have square brackets, what I'm trying to do is I'm trying to say whatever index is inside the square brackets, get me the value of this list and that index. Okay. So firstly, my question to you is, what is A1? What is the item that lives in the first index of A? Any ideas? Notice that our lists are always 0 indexed. Okay, let's just guess a value for our variable value. Because I know this is new material, people are shy, but okay. Someone who has guessed what value will be evaluated to, can you show me the number on your fingers? Okay, so a lot of us have a guess, but don't want to say it out loud. Well, exactly, that's what's happening. I'm saying A1, 0. Now I look at smaller chunks left to right, right? In Snap, I was looking inside out. Here, because I have no brackets, no nesting, I'm looking left to right. Firstly, what's A1? Well, I go to the list A, I say, what lives in the first index of it? This list right here. So A of 1 just becomes a list that contains 4. Now I have A of 1. Now I index into whatever A of 1 gave me. I treat that as a list and I say, what lives in the 0th position of whatever A of 1 was? Well, this is A of 1. In the 0th position, we have 4. So value just becomes 4. Can I see thumbs if that made sense? Awesome. Okay, more of us are happy. Okay, any questions? Yeah. Sorry? So I had this assignment statement where I said value is equal to A10. A of 1 evaluated to this list 4. So A of 1 is just this list 4, right? And then I looked at the 0th index in this. Now, when I look in the 0th index, I get this number 4. Since the number itself is immutable, whenever I assign a variable, in this case value, to that number, I will not draw a pointer. I'll just copy over the number. Does that help? Awesome. Any other questions? Okay, so then let's see what happens. Well, value just becomes 4 as expected. Okay, great. Now I say C is equal to A of 1. Now this is interesting. Okay, now think about it and try to guess what's going to happen here. Any ideas? Yeah, exactly, right? Well, I say, okay, A of 1, what are you? Well, I look at A. A has a list. A of 1 is just a pointer to another list. So C becomes exactly what that pointer is. C just gets a copy of that pointer. It points to the same position that A of 1 was pointing to. Okay. And then I have C of 0 is equal to 6. So now this is even more complicated. What's happening here? Well, what's C? C is this pointer. I am assigning to whatever list this points to, the 0th index of that list, I am assigning the value 6. So in this list, I go here to the 0th index and I make it 6. Okay. Now I say print value. Well, value is 4. It just remains 4. So it's going to print 4. Print A of 1 of 0. So A of 1 is just this list, right? This is A. At the first item, I have this pointer. So I have A of 1. And then what's the 0th item of A of 1? Well, the 0th item is just 6. So it prints 6. Can I see thumbs if this made sense? Okay, so now since we're on a time crunch, I'm going to go a bit faster. But these are the basic rules you need to know. Okay, next. Yeah, so the other observation I already mentioned, so I'll skip over it right now. Now, the next thing we need to know are some list methods. The first list method that mutates a list is the pop method. The pop method, basically the way you use it is you use the list name or the list reference dot pop and you supply an index. The pop method will remove the item at that index and return it, okay? If you don't supply an index, like here where I haven't put in an index, it'll automatically just assume you're talking about the last item. So I'll remove and return the last item. Then we have append, which takes in an item and places it at the end of a list. We also have remove that takes in an item and removes the first instance of that item from the list. Note the difference between pop and remove. Pop takes in an index and then removes the item at that index. Remove just takes in the item directly and removes the first appearance of that item in a list. Okay, so it's okay if you didn't get all of that right now. Refer to the slides again. This is pretty straightforward. Let's look at an example using these methods. Okay, so I have a list called CS class. It points to a list containing CS61A. So 61 and A are also their own values. Then I say my class is equal to CS class. Well, since CS class is a pointer, I just copy over that pointer. Great. And then I say mystery1 is equal to my class dot remove A. Firstly, remove will remove the first appearance of a given item in a list. So I see that the list changes. But if you notice here, I said remove just removes the first instance. It doesn't return anything. Okay, so this is just a little caveat to see. Yeah. What I'm trying to say is, suppose you have a variable and you assign it to list.pop something. Okay, so if you say x is equal to list.pop something, whatever is popped gets stored in x. But if you try to use assignment with append and remove, you'll get nothing. Okay, awesome. So don't worry about this point too much. This was just to make sure we're paying attention to definitions. Okay, so mystery1 is none because, well, remove doesn't return anything. What about the next one? I'm popping the item at index 2 in the list. Item at index 2 is 6. 6 gets popped, and then mystery2 gets whatever 6 was. Why? Because pop will actually give you back the value. Great. Now I append 0. Well, clearly returns nothing. Again, I append 0, returns nothing because append doesn't return, only pop does. And then what I say is my class.pop. This time I don't supply an index, so it just assumes that I'm talking about the last value. I pop the last value and place it into the variable. And I end up with CS10. Thumbs if that made sense. I know I'm going faster, but I'm happy to see the response. Any questions? Okay, moving on to the next thing. We did our example. Now we'll talk about some operations that don't always mutate lists. And I say always because some of you will look it up online and say, hey, no, you can mutate a list with this. Well, in this class, we won't. In future classes, you will. And I'll tell you when and where that happens. Okay, so let's start with list comprehensions. The syntax for a list comprehension is we put in our square brackets, then we say a map function, where map function is just some function, called on a variable for variable in list reference if keep function on the variable. This is gibberish. This is absolute nonsense because if you just say it out loud, it makes no sense. We're going to look at examples and it'll click. Okay, so what this does is it creates a new list. This new list is the copy of a provided list. So it's not pointing to the same thing, it's creating a new list, okay? And in this new list, the map function is applied to every item in the list that you passed in. It's just like map and snap. But if you also use this if condition, you can do both map and keep in the same line. If you don't understand this, just wait for the examples, it'll click. Okay, so yeah, let's look at an example. So the first thing I do is I create a list called nums where I have 1, 2, 3, 4, and 5. And then I say add 1 is some variable that I'm assigning to. Now I have this list comprehension syntax, which says nums plus 1 for num in nums. Okay. Looking back at the previous slide, nums plus 1 is my map function. Nums is num is my variable. So I'm saying num plus 1 for num in nums. So this num refers to every single item in nums, adds 1 to it, creates a new list, spits it out. So then what do we get? Don't worry about the iterator instance. Look at the final result. That's 2, 3, 4, 5, 6. If you want to know more about the iterator instance, 61A. Okay. Can I see thumbs if this example made sense? Any questions? So you take in a function, apply that function to every variable in a certain list. Yes. Yeah, sorry, I'll do that. Awesome. Okay, so then we look at the next example where we're sort of implementing keep. And what we're saying is num for num in nums if num mod 2 equals 0. So the first thing I notice is I'm not doing anything to the variable. I'm not adding 1, multiplying by 2, nothing of that sort. I'm just saying for every single item in the list, keep it if that item is even. If num mod 2 equals 0, that means the item is even, okay, by definition of the modular function. This num is just a variable that I'm binding to every single value in the list, or that I'm using to reference every single value in the list. So now question, if you have 1, 2, 3, 4, and 5, what is even going to return? Looking at this list comprehension, what do we think? Does someone want to try? The answer is in the name. Yeah. Perfect. It'll just return. Wait, no, 2, 4, because there's no 6 in the list. So yeah, makes sense? Like the original list didn't have 6. Awesome. Okay, and then what if I want to map and keep? Well, now what I'm doing is I'm saying for all the items that are even, I want to add 1 to it. Okay, so I'm saying num plus 1 for num in nums, which just means for every item in nums, if num is even. So if the item is even, add 1 to it. If it's not even, just ignore it. Okay, so now I get precisely the last list, but with 1 added to everything. Because it keeps even items, then it adds 1. If this doesn't make perfect sense right now, wait till discussion. We're going to go over more detailed examples of this there. For now, we'll move on to the next concept. Well, yeah, as I said in 61A, you may learn how list comprehensions can also mutate lists, but we'll skip it for now. Now, one of the last things we'll cover today is list slicing, which is just a way of getting a slice of a list, which means a certain segment of a list. List slicing creates a new list with items that begin at index start and end at index end minus 1. So keep this in mind. The second thing that you give it, that index will not be included. It'll be skipped. It'll stop 1 item before that. Okay. And then there's an optional argument called step. Don't worry about that right now. So it starts at index start and it ends at index end minus 1. And it gives you all of those values, but in a new list. Okay, so let's look at an example of that. Now, this one is a little more involved, but let's look carefully at what's going on. L points to a list that contains 1, 2, 3, and 4. X is equal to L sliced between 1 and 3. First thing is, how many or what items do you think X will contain? Does anyone want to guess? Remember, it starts at the first value and it ends at the second value minus 1. What do we think? Cynthia? 2 and 3? Let's see. So it contains 2 and 3, precisely, because it starts at 1 and it ends at 2, right? Okay. Ends at 3 minus 1, which is 2. So only 2 and 3. Excellent. And remember, it creates a new list. So now we're seeing another thing that creates a new list besides the square brackets, the list comprehensions. Okay. And then the next one is saying L from 1 to 2. What might this do? Well, it starts at 1 and it ends at 1. So clearly there's going to be only, the second item here. A quick way to see this is to see if both of these are positive, right? The result of your list slice will contain this minus this items, okay? So in the first case, it contained 3 minus 1, which is 2 items. So this has 2 items. In the second case, it contains 2 minus 1, which is 1 item. Well, then things become a lot more clearer. So it's a way to do a sanity check. This will only work if the 2 start and end indices are positive, okay? And then the next one, well, it will contain 0 items, right? If you start at 1 and then you end at 1 minus 1, it makes no sense to have any items whatsoever. Okay, and then we'll go over, well, we'll skip the step for now. Step just means that you skip every nth item. So it'll go over the same list, it'll start at 1, it'll end at 3, but it'll jump 2 items at a time, okay? So it'll say 1, and then it'll jump 2 items, and so on and so forth, okay? Now we're going to look at a few special forms of list slicing. The first special form is start : nothing. What this does is it returns a copy of the list, which is a new list with items starting at index start and ending at the end of the list. So it's almost like saying start and then forever, as many items as you have. The next one is when you do the opposite. You say, well, : and then your end. Now it starts at the beginning and it gets every single item till 1 before your end. Okay, so always the right one is exclusive. Great. And then we have, well, you provide nothing. And so it automatically says start at the beginning, end at the ending. Then why am I using it? Why am I just not using the original list? Because slicing creates a copy of the list. It creates a new list. So if I had a list and I wanted a copy of that list, I might just slice it with no arguments given. Okay. And we'll quickly look at a few examples of that. Everything until but not including index 2, everything from index 1 and onwards, and then the whole list copied. What I want you to take away from this example is that it always creates a new list. It's not changing the original list in any way. Okay. So we'll go back to our example. I wanted to give you one more example here, but I feel like that example is slightly challenging. I think it's still a good idea to look at it, but do keep in mind that this is pretty damn tricky. So it's okay if you don't get it. But I still, want to kind of give you an intuition of what's going on. So let's look at this example. First, I create this list for A. A is a list, right? This square bracket creates a list. Within A, the first thing it contains is the item 1. The next thing it contains is itself a list. So we make a new list and we draw this pointer. The third thing it contains, same deal. It has a new list, so we draw the pointer. And the last thing it contains is the number 3. Can I see thumbs if just this bit makes sense for now? Okay, everybody feels good? Great. Now what I'm doing is I'm saying B is equal to a copy of A. Here's what I want you to keep in mind. When I'm making a copy of A, I am literally doing exactly what I would do if I were assigning variables. If it's an immutable thing I'm copying, I just copy the value over. If it's a mutable thing, I draw an arrow. Okay. So now let me do this on the board first. So A contains 1, a pointer to a new list containing 1, a pointer to a new list containing 2, and then 3. Okay. And now I'm setting B to the result of copying this list. When I copy a list, I use exactly the same rules as I would use for assignment. The first item of B, so let's start a new list first. It always creates a new list. The first item of B is the same as the first item of A. So it's just one. The next item is the same as the next item of A. But what's the next item of A? It's just a pointer, right? So I use the same rule I would use with assignment statements, and I copy over that pointer. Okay. The next item, again, is just a pointer. Or you can think of it as the next item is a list, so I must draw an arrow to that list. Great, I have an arrow to that list. And the last item is just 3. So I end up with 3. The cool thing to note here is that although when I slice and I make a copy, I make one new overall list, I don't actually make any more lists beyond that. Beyond that, I just copy the values. So in the end, these two lists are unique by themselves. Can I see thumbs if this made sense? Ignore the words, just the diagram. Does that make sense? Okay, most of us are happy, so let's just verify our answer. This is this very weird looking diagram. I wish I could move the lists around, but yeah. Okay, that is about all I had for you today. There's 2 things I wanted to mention before you leave. The first one is that Philip Gore, he's a postdoctoral researcher at MIT. He made Python tutor. So it's because of his efforts that we could do all of this today. The next thing is that the lecture check-in questions are hard. But the reason I'm still giving them to you is because, well, you have Python tutor, right? If you're not sure of an answer, feel free to use Python tutor, play around with it, but make sure you understand the correct answer before you bubble it in. Awesome. I will see you in discussion soon. Thank you. Any questions, by the way? Yeah. Sorry. Yeah. Oh yeah, 6 to 8. Yeah. It's in the weekly blast also. Yeah. Yeah. Yeah, we can look at it. Do you mind showing the deep shot? Oh.